Welcome to 11.3, Hyperbolas and Writing Equations. So this section here on 11.3 is going to be focused on just writing hyperbolas from 0, 0. So everything's going to be centered there, and then we'll add in h and k in the next unit or the next section. So a hyperbola is basically a double parabola that opens in two directions. Normally parabolas open up and down, but we're going to see that our hyperbolas are going to open one of two directions sets. So one version goes left and right, the other version opens up and down. The way that we can tell is based off of whichever variable between x and y comes first. So since x is in the first spot above our a squared value, that is going to go left and right. And then when it opens up and down, y is going to be the variable that we see first, which makes sense because y moves up and down, x moves left and right. And this is just a kind of a general shape you're going to see. So the left and right ones are going to open here like this, and the up and down ones are going to look something like this. And the center for everything we're doing in this section is 0, 0. One other thing I just want to make note of. Notice that the a squared value comes first in both equations and b squared comes second. So it does not matter what the bigger number is anymore, like it did for ellipses. Now it's whatever comes first. A squared always comes first. And the b squared will be the second part. Which is why we can have this new foci formula here. C squared is equal to a squared plus b squared. So now we're adding in our foci formula rather than subtracting like we did with the ellipses. So there's a lot of similarities between them. We do see an x squared underneath a squared and kind of a changing of the order with our fractions. But the biggest difference that you'll notice in the general equation is that it's a minus sign in between them. Okay? So the way that I like to remember it is if the original equation is minus here, then your foci formula is positive, plus sign. So let's go ahead. We're just going to skip the graphing a hyperbola chart here. You can read through that, but I'm going to just jump right into the problem and work through the process, and I think it'll make more sense. So let's just identify a couple of things. Notice that we are leading with x squared, which means that our hyperbola is going to go left and right. The other thing we want to note is that it's always a squared first from now on with hyperbolas, not with ellipses, but a squared is underneath the x squared, so that's why it's going left and right. And since our a squared is 9, our a value would be 3, and our b value would be 2. And our center is at 0, 0 for all of the ones in this section. So here's 0, 0. From here, we are going to go left and right by 3 because our a value is under x. So 1, 2, 3, 1, 2, 3 to the left. And those are the coordinates that we want to write down. We're going to write 3, 0 and negative 3, 0 because our a value goes with the vertices. Now we're going to also go with the b value. We're going to go in the opposite direction. I'll go a different color here. But these do not have a special name. These are not the covertices. We've actually dropped the idea of covertices for this. The purpose of this is so that we can actually create a box. So what I'm going to do is using the dimensions of these points that I've graphed, I'm going to create a rectangular box here with dashed lines, because this is like an invisible box. We wouldn't actually see this if we graphed it on like Desmos or something. And then it's going to create asymptotes. If you remember, asymptotes are those invisible boundary lines that we will get very close to but will never actually cross. So what I'm going to do is put some dashed lines going through the diagonals of the box. This is going to help give us shape and form to our hyperbola so we know how wide or narrow our graph is actually going to look. So you have to imagine that our hyperbola is restricted inside of these lines. All right, now we're ready to get the actual shape. Now that we have our asymptotes, we know that our foci are vertices are 3, 0 and negative 3, 0, and we know it's going to open left and right. Then we're just going to make sure that we don't cross the asymptote lines. We can just get really close. It doesn't have to be perfect. Something like that is good enough. And now this is also kind of a new piece, but the asymptote equations, for everything in this section, we're going to simplify this formula down. We're going to just treat it like plus or minus mx. If you remember, m represents the slope. So the way that I'm going to figure out the slope is based off of the a and b values of the box. So looking from my center here, I wish I had a pointer, I'm going to go up by 2. So I'm going up 2, and then it goes across by 3. So the slope of our asymptote is y equals plus or minus 2/3 x. The reason it's plus or minus is because we have two asymptote lines. We have the positive asymptote line, which is the one I marked with the 2 and 3, but we would also have the negative version if I were to go down and over. So then I would have -2, 3. So we just do plus or minus to save ourselves the time on that. Finally, we're ready for the foci formula. Remember that this one is now a squared plus b squared equals c squared. A squared is our number before, which was 9. B squared was 4. And together, they add up to make 13. And we want to take the square root of that number, just like we've done in the past here. Unfortunately, 13 is not a perfect square. We just know that it's a little bit less than 4. It's going to be between 4 and 3. I'm pretty sure it's like 3.4 or something like that, 3.5. So if I were to graph that, it's just going to be slightly past our points here. So rather than be inside of the box, it should always be outside of the box, and it follows the direction that your hyperbola opens. When you write the coordinates, since these ones are going from 0, 0, we're adding and subtracting to our x value. So it would be the square root of 13, 0, and minus square root of 13, 0, because I moved left and right with these ones. And with that, we graphed our first hyperbola. So I'll just let you get that down here, and then we're going to move on to the next one. Now we're going to graph a different type of hyperbola, because notice y squared is our first part. So this one is going to go up/down rather than moving left and right. A squared is still the number that comes first. B squared is the second number. So from this one, our center is 0, 0. Our vertices will come from the a value after we mark those. So up 1, 2, 3, 4. Down 1, 2, 3, 4. So 0, 4, and 0, -4. And then we're going to go left and right by 3. And we're going to create our box so that we know how to graph the asymptote lines. All right. Now that I have that, I'm just going to draw my diagonal lines here. Doesn't have to be perfect. Just do the best that you can with it. This just gives it a little bit better shape, so we're not guessing as we're drawing these. And then just remember, it's also opening up and down this time. So make sure you don't cross the asymptote lines. You just draw your hyperbola going both directions. And now we're ready for the asymptote equation. This time, because our a and b values are in a different order in terms of x and y, this time our rise is going up by 4 and our run is going across by 3. So the slope, our m, is 4/3. And we saw those numbers earlier because our a value was 4 and our b value was 3. I forgot to mark that earlier, I apologize. So the final equation is y equals plus or minus 4/3 x. We will add in the y1 and x1 eventually, but since we're starting at a center of 0, 0, it doesn't actually matter for this one. Now we're ready to do the foci. A squared plus b squared equals c squared rather than minus. So that goes 16 plus 9 equals c squared. That makes 25. And we get a perfect square for a change. So 5 is our c value. So from our center point, following our vertices, which go up and down, we're going to mark our foci above and below that. And they have nice coordinates. They're not radical answers. So it goes 0, 5, 0, -5. And I'm just double checking, make sure we listed our center, our vertices, asymptotes, and finally the foci. And we have everything on the graph that we need. Okay, now we're gonna go down here. For the sake of length on this video, I might not do the entirety of this problem. I might just look at a few things, but remember, whenever you end up in a situation where it's not equal to 1, you just want to divide by whatever your number is. So in this case, I want to transform that 100 into a 1, so I'm going to divide all of these by 100. I would get x squared over 4, because there's 25, or 4 groups of 25 in 100, and then I would get y squared over 25 equal to 1. And now I have it set up appropriately. Because x squared comes first, that causes it to go left and right. And this is another thing that it's going to feel a little strange at first, but notice how our a squared value is actually smaller. That is going to throw you off a little bit, something you're going to have to get used to here. So then your center is 0, 0, and your vertices are, since our a value is 2 and our b value is 5, we're going to go left and right by 2 because it's underneath the x. So it goes 2, 0, and -2, 0. Then we're going to go up and down 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, down. And I know it seems strange because the long part of this usually would be our vertices, but it's just whatever the a value is underneath, which in this case was x. Okay. And now if you were to make your diagonals going through this, it would look something like this. This time the rise over run, it goes up by 5 and over 2. So it would be plus or minus 5 over 2x. And our foci formula, a squared plus b squared equals c squared. A squared would be 4 plus 25. So we get 29 is the c squared. Take the square root of that. So the square root of 29 is our c value. I forgot to actually draw this. Since it's opening left and right, it's a super, super wide parabola, or hyperbola. And the square root of 29 is a little bit bigger than 5. It's like 5.3, 5.4, or something like that. So I'm just going to put a point that's 1, 2, 3, 4, 5, and a little beyond that out here. 1, 2, 3, 4, 5, a little beyond, because it has to follow the direction that it opens. And the coordinates for that would be square root of 29, 0, because I went to the right, and I went to the left, which is negative square root of 29, 0. Now we're ready to try one of the reverse problems where we're going to write the equation rather than graph it, which we have a graph here to help us out. So they told us that the center is at 0, 0, and then they told us our vertices are at 0, 5, 1, 2, 3, 4, 5, that goes up 5, and 1, 2, 3, 4, 5, that goes down. Whichever direction your vertices go is going to tell you the direction that it opens. So this one would go up and down, and if you remember, the up and down equation starts with y squared. So y squared minus x squared over b squared equals 1. So this is what we're trying to fill in. Now that we've established that y is the first part of the equation, now we need to think about the value of a, b, and c. Remember that a goes with vertices, c goes with foci. We unfortunately don't have a co-vertices like we've done in the past, so we need to find the b value through an alternate method. But the vertices here, since the distance from 0, 0 to any of these points here is 5, that means your a value is 5. So we can note that a equals 5. And then to find the c value, we could graph 0, 13, 0, -13, which would be like way above and below, but it's just a distance of 13. Now we want to use our a squared plus b squared equals c squared to connect it all. So this would be 25 because it's 5 squared. This would be 13 squared is 169. And if you subtract by 25, you get a b squared value of 144. We could find the regular b version, which would be to take the square root of 144, but we don't need to because now we have everything we need for the equation. So it would go y squared under 25, because remember, a is 5, b is 12, and then minus x squared over 144 equals 1. Moving on to our final one that I'm going to do here with you before the end of the video. This one has a center of 0, 0. It has vertices at -4, 0, and +4, 0. So this one is going left and right instead of up and down, which causes it to go x squared first, y squared second, equal to 1. So just like before, our a value is the distance from our center to each of these. It is 4 away, therefore our a value is 4. They didn't give us the foci, but it actually doesn't matter because they gave us the asymptote equation. They said it's plus 3/4 and minus 3/4. This 3, if you remember, is part of the equation that our box would come from, so that's actually the b value, just kind of disguised. So now we have everything we need. It would go x squared over 16, remember to square your a value, minus y squared over 9, because our b is 3. And that's the equation. All right, I'll see you guys in the next one.